So now let's explain the term electric potential. Now I've explained electric field from episode 1 of this topic. I've explained electric field. I've explained electric field intensity. That's what I did now. So the next thing that I will do is electric potential. What do we even call electric potential? I told you that firstly the symbol for electric potential, it is V. What do I call it? It is what? It is V. That is the symbol for which is this V. That is the symbol for electric what? Potential. Hope I'm communicating. Note that. And the names that they call this electric potential, it can be electric potential, it can be electromotive force, EMF, electromotive force. It can also be potential difference, PD. It can also be voltage. All these names, we call it all electric potential. These are the names that we can call V. Call it electric potential, potential difference, PD, EMF, electromotive force, call it voltage, all together. So these are all we can actually call this particular V. Are we? And note, its SI unit is what? Its SI unit is volts. Its SI unit is what? Volts. I will still tell you substandard or some derived unit for this V. How together? Now note, let's quickly explain what is electric potential. When we say electric potential, let me firstly come, because I will prove like 3 formulas in this electric potential as well. Electric potential, let me use this one, is as a result of, let's make V the subject of the formula here, which is the electric potential. It will be what now? It will be, this is over 1. V times 1 will give us what? V equals to E times D will give us what? ED. This is the first formula for calculating the electric potential, or potential difference, or electromotive force, or voltage. Where E stands for, you have know that, electric field intensity. Where D stands for what? Distance. And I told you in some textbook, they can use V equals to ER. It's still the same thing, irrespective of, D is distance, R here is also distance. Are we? Now let's define electric potential according to this formula. It could be referred to as, for those jotting, it could be referred to as the product of electric field intensity, as the product of what? Electric field intensity and its distance that tear them apart, and its distance that do what? That tear them apart. Hope I'm communicating according to this what? According to this formula expression. Its SI unit, according to this one, its SI unit is now what? It is volts. That is the standard fundamental SI unit. The substandard one, this is E. E is Newton per coulombs. I've told you that is the SI unit for what? For E. Then SI unit for D, the standard SI unit is what? It is meter. But what is the sign that is joining E and D? It is time times meter. This is derived unit. Now, when I said this times this, it will be N all upon, let me break it, N all upon what? C times M. N times M will give me what? Nm, Newton meter. Then this divide. This is over 1. C times 1 is C. They are divided. Put it here. Then put columns here. It will now be Newton meter per coulombs. This is this derived or subunit for SI unit of what? Of voltage. Voltage is the, so if they say 12 volts, know that it is electric potential they are saying. If they say 12 Newton meter per coulomb, it's still the same thing. So JAMB might ask you, the SI unit, the derived SI unit for electric potential, according to this formula expression is what? This is the derived SI unit. Why the fundamental one? It is volts. Hope I'm communicating. So, and the next, what again that they can actually ask here, or let me put it like this. This is the first one. This is the first formula. The second formula that I'll put in here, of course, we need all these things. The second formula for calculating electric, if the question implies you didn't see E there, you can't find D there, electric field intensity or distance. The another formula that, and you in the question, in the calculation, you see work done and you see electric charge. You can't use this one. What is the one that I use? Please cram that. It is W, which is work done, all upon what? All upon Q. W stand for work done. Y Q stand for what? Stand for electric charge. Electric charge. So that is the symbol. So what is the SI unit of this one? It is what? Joule. That is the standard SI unit for work done. Because work done is an energy under dimension. While this Q, it is SI unit for electric charge, it is coulombs. Coulombs. Are we together? Why it is C. Now divide, this is the divide. The standard fundamental SI unit for this particular topic, it is joule per coulombs. So that means we can electric potential can have Newton meter per coulombs as an SI unit. Can have what? Can also have volts. Can also have joule per what? Joule per coulombs according to this certain proving. Oh, this is the second one. Then the last one, the last electric potential that I'm going to put is the same thing as V. V. What is that V? Aha. Now that last V is when you have. So in times, if in the question, in some calculation, I have my reason for proving all this formula. In some calculation, you see distance there, which is R. You see E naught there. You see pi there. Then you can't use this. You can't use this. And you have to calculate electric potential. What is the formula, which is the last formula I'm going to be proving under this one? The formula that you use is... So let me define this now in terms of this one. It is the what? It is the ratio. It is the ratio of the total amount of energy per unit electric charge. This is another definition for electric potential. Are we together? And the SI unit is joule per coulombs. I've explained how that is. Now the next one, know that even Newton per coulomb, Newton meter per coulomb is still the same thing as this. Volt is still the same thing as this. They are all for V, electric potential. Are we together? Now the next thing to do now, since the last formula under this V is that when you have E naught in your question or you have R in your question, what and what? There's no E naught here, there's no R. What is the? And this particular question that I'm about to, this particular last proving, is when I'm reviewing jamb past question, you will see this particular last question here. So if you know it now, it is a bonus. Even before I start doing it, I know you will be able to tell me, because I know I'm speaking with honorable peoples, well-respected peoples here in the platform. So now what follows is that when you have E naught, you have R, you have Q there, what you come to your mind is that they are related to in terms of Coulomb's law of electricity. Where we have, what do we have? We know that we have V. V equals to ED. This was formula. For we to get this, how do we get? And note that E, I told you that E is Q all upon what? 4 pi E naught R square. Are we there? I've proved this. Wherever I'm saying E now, what will I be putting? I'll be slotting in all these parameters inside this formula. Are we together? I'll be slotting in. I will be substituting in all these parameters, all the value for E, all this something inside this. So for we to be able to arrive at this something. So which will now be V equals to Q, this is E, which is all this. Q equals to 4 pi what? E naught R square times, it is times that is joining this and this together. And I told you that this can also be the same thing as V equals to ER. It's still the same thing. So wherever I'm saying D, what will I be putting? R. Because I told you, based on this R that I'm having here. So R, which is this one. Or you can put this square here, you put D here. Anyhow it is. But mostly they use R. So I would prefer you using this one instead of this one. So wherever I'm saying D, I'll be putting in R. I told you that D can also be R. R can be D. As far as this topic. Now R here, settle 1 R here. Remain how many R here? 1 R. So V now will now be Q all upon 4 pi E naught R. This is another formula for calculating what? Electric potential. Q, pi, permittivity, free space, and distance. So this is the last formula under this. Let me quickly join that, and I will be reviewing some questions backing all what I'm proving. So let me quickly, please, all you need to do, cram the formulas, all these formula, electric field potential, electric field intensity, cram all these formula, this proving very well, because they do ask. It's a very repeated question that they do ask at JAMB, and even for those preparing for work. The last one, which is the work done. Work what? Work done under this something. Actually, you know what we mean by work done. It is the product of force or a moment and its distance. Are we together? That is it. And you know, normally, JAMB might now ask you calculate the work done under this subtopic, electric field intensity, or relate work done in terms of electric field intensity. Meaning, maybe you are asked to calculate work done. What is the formula for work done? It is force times distance, isn't it? Or in that work done, you have Q there, you have E there, you have R there, or D. I told you R can be D. And you have to calculate work done. Is it this formula that you are going to use? No, not this formula. All you would use here, or what are the things to use here? If you have Q, E, and R, and you have to calculate W. So you have to find a means to slot in, to find a means to arrange this F. How do we arrange that? Recall that electric field, you know this is electric field intensity, this is electric charge, this is the distance. Recall that E, which is electric field intensity, that is the symbol, is equal, the first formula is F all upon Q, isn't it? What do I make? This is F. What do we want to make the subject of the formula? F E times Q. So whatever I'm seeing F, I'll be substituting in the value of F here. E times Q, it will give me what? Or put 1 here. F times 1 cross multiply. F times 1 will give us what? F. E times Q will give us what? EQ, right? So this way, wherever I'm seeing F now, what will I be putting? This is F. I'll be putting in what? EQ. So it will now be W equals to, what am I having? EQ times, it is times. I told you that this D, you put it here. Which will be W equals to what? EQD. Or it can be W equals to EQD. I told you it can also be the same thing as EQR. This is the formula for calculating what? Work done. Under this what? Under this electric field intensity or electric field or electric what? Potential. These are the little derivation that I'm going to be doing. The next class on this one is just to bring in the what? The past question. What are the questions? So we'll like treat 4 to 5 questions under this. And believe me, if you stay tuned and stay connected with us, you will love this class and you will enjoy it. This topic is a very common topic that they do ask, mainly as JAMB is concerned, as WAEC is also what? Concerned. Thanks for watching.